Okay, I think we are recording. Yes, we're recording. This is ITS 148, and today's October 15th. And so today we're starting chapter 9, and we are somewhere around, today is October 15th, yes, like around here, working with dates and times. This is a pretty short chapter. Let's take a look at some slides. Chapter 9. I'm going to save them down here someplace. And then I can open them here. All right, so we're doing chapter 9 here, so I'd like to go through these slides first. And you know a lot of this already. It's dates and strings, and you know, dates and strings are complicated because, you know, with dates, you know, you're counting seconds, minutes, hours, and so on. The dates and months have different days, depending on the year and all that. So the date class has all kinds of methods in there to help you manipulate dates, all the different ways that you'd like to manipulate them, all the different ways you'd like to display out a date, or display out the time, 24-hour time. Sometimes you put the month before the date, day before the year. Sometimes you put the year before the month before the day, and all that. It's all built in. They've thought of everything. And then with strings, there's lots of things you want to do with strings. Like sometimes you want to, like, split a sentence into words. You may want to trim the spaces off. You may want to capitalize some stuff. All that kind of stuff. You want to see if a string begins with a certain substring or ends with a certain substring. There's a whole bunch of methods for strings too. And so we're going to learn all about that. String handling requirements of an application, formatting requirements using the format method. There's a nice format method, and there's a string class. There's something called interpolated strings to help you format even more. There's the string object, which is different than the string builder object. They do this kind of the same thing, but it's just two different ways, very similar ways, but different ways of building strings and manipulating strings and storing them and comparing them and so on. So to start out with, there's a couple of three different ways that you can create a date time value. First of all, there's a class, a date time class. So when you declare a variable, you're gonna you declare a variable, you know, this variable name, and then the type of the variable is not int, it's not string, it's not decimal, it's date time. So a date time string, and so you can create or instantiate or create a brand new instance of a date by using this new date time builder, this method here, which and you can specify the year, month, day, hour, minute, seconds, and even milliseconds to initialize that date value. There's also a parse method. You can you can declare a variable, a date time variable, and then you can initialize it by using this parse method, and the string can be some way of expressing a date, a common way of expressing a date. Like if you say, you know, October 15, 2019, and that's the string, and you parse that, well, it will understand what that means, and it'll convert it into a variable, and it'll store that date into a variable, and then you could do things like add 5 days onto that, and it turns into October 20th, or you can add, 12 hours and, adds to the time and all that kind of stuff. Another way is there's a try-parse method, which will, of course, first test to see if it's possible to parse. And if it is possible to parse, it goes ahead and parses it. If it's not parsable, then it returns a false and does not change this variable name value. So it's similar to this DateTime parse, try-parse with the plain old parse. Of course, if you try to give it a string that cannot be translated into a date or date time, then it throws an exception. So here are some examples of some statements that can be used to create date time values. Here's one that just creates one. Creates a variable called start date, and start date is equal to January 30th, 2016. 12 a.m. to be exact. When you don't specify the time, it assumes 12 a.m., which is, of course, the very beginning of the day. You can do it this way. This specifies more than just January 30th, 2016. It also says it's 2:15 in the afternoon. This one here uses the parse method, and so it parses this string here, 1:30:16, and that's the same as this one up here, this top one. And so there's a regional time setting in your computer, and the regional time setting in all of these computers here, what we use is America. We do month, day, year. Other countries, of course, as you know, do it differently, and the regional settings will change. The Visual Studio or C#, the C# compiler is aware of the regional settings. Yes.
What was the 0 and the 4th line for the line that has 2?
Here?
What is that?
That must be seconds. 0 seconds. Hours, minutes, seconds. You can even have milliseconds. Optionally, you can have milliseconds too. Here's an example where it takes, it parses this Jan 30, 2016, 2:15 p.m. It's smart enough to look at that and to parse it just like if it were this one up here. These are example valid date formats. And I don't know, there might be more of these, but these are all pretty obvious ones. Valid time formats, of course. The nice in programming and in databases, we like this one here, this 2016-01-01 for January 1st, 2016. We like that better. Why? Because if you just treat this as characters, let's say it's not a date. Let's say you're just treating it like a string of 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it turns out that if the date is written in this format, then this string, if you want to sort the dates, the sorting works if this is a string or this is a date and a time, because the highest order is up here, is to the left, and then the month, and then the day. And so if you have a bunch of dates that are in this format, you can sort them, and they'll be sorted in chronological order. So there are some current properties in a date time in the DateTime class, or the DateTime static class, which will return the current date time, and that's the now. So if you do DateTime.now, that's going to return exactly what what date and time it is at the time you execute the statement. So that's another way of initializing a variable. And this is the today variable, or property. You may recognize that from Excel. Yeah, but there's a today function, and that returns the date and not the time. It returns 12 midnight as the time, 12 midnight a.m. Here's some ways. There's some built-in methods where if you don't want to bother trying to figure out a way of manually formatting a date to a particular format, if you're happy with January, if you're happy with October 15, 2019, October all spelled out and everything, you can just do two long date strings. So you take the date time, your date time variable, and you do period. This method, it's gonna return a string that's got it's formatted that way. There's a short date time, which is shorter. To give some examples here. Let me first, okay. Two time and short time, long time and short time, long time, short time. Okay, so here's an example. Let's say you've got let's say you have a variable called, let's say you have a date time variable called current date time, and that contains January 30th, 2016, 4:24 and 59 seconds in the morning. So that's the value of current date time. Well, if you do this .to long date string, then it's going to return this, the whole word Saturday, comma, space, January, space, 30, comma, space, 2016. Okay, that's long date time. Long date. Short date is just 1/30-/16. Long time gives the hours, the minutes, the seconds, gives the whether it's AM or PM, and short is just the hours and the minutes. And the format that's used for a date or time depends on your computer's regional settings. So here are some properties for working with dates and times. So you can use these to connect them with your variable, with your current date time variable, and you can just take these components of a date time variable and just grab those out if you want to. For example, let's say you got a date time variable called current date time, and it's right now or whatever. If you do the .month property, you're just going to get the month, the value, the integer value. If you do the .hour property, oh, by the way, these are actually numbers that are coming back, not strings. If it's just the hour property, it's going to return the 10. It looks like it's 12-hour time. No, I don't know if it's 12 or 24. You have to test it. If you, it's probably 24-hour time. If you do the day of year, it's going to return the day, an integer, which is the day of the year, up to 365 or 366. This is going to return the number of days in a month. So here we're returning the number of days in February of 2016, which would be a leap year, which is why it returns a 29. And this is a simple dumb method that would return whether or not it's returned true or false, whether or not it is in fact a leap year. And this is there's an enumeration type that where you can test to okay, so this day of week thing is just sort of it returns a number between 0 and 6 kind of, but if you want to test it and you want to think in terms of days of the week as opposed to 0, 1, 2, 3, 4, 5, 6, then you can use this enumeration type here, where you know, you can test it this way. You can test if the day of the week is Saturday by testing if day of week is equal to day of week dot Saturday. You know, so this is a capital D, this is a lowercase d, lowercase day of week, that's the actual variable, and capital day of week, that's the class. And there's methods, and these are methods for methods for performing operation on dates and times. So let's say you have a date, a date time variable. Let's say you have a date time variable called current date time, and you want to you follow that with this method dot add days, and you say 5. So you can add 5 days to current date time, which let's say it's January 30th. If you add 5 days, it's going to bring it up to February 4th. Let's see, 31, 1, 2, 3, 4. Yeah, February 4th. So you can add some days onto a date time. You can add some months onto it. You can add some years onto it. You can add some hours to it. You can add some minutes to it. You can add some seconds to it. You can add a time span to it. What's a time span? Well, you'll notice in all these other cases, 1, 2, 3, 4, these other 6 cases, we're just adding a single thing, like some number of hours or some number of years. Well, let's say we want to add 5 hours and 25 minutes. Well, that's a time span. That's a span. We want to add the span of 5 hours and 25 minutes. So that's just, you know, we just put 5 colon, well, however we express it. We'll see an example here. But anyway, that's this add. So this is kind of a general, more of a general add in case you want to, what you want to add consists of days, hours, minutes, seconds, or whatever. That as opposed to just adding a 5 days or whatever. And you can subtract a date. You can have a date and a time, and you can have a date time variable, and you can subtract another date time variable, and that's going to return a time span. So like if you have October 15th, 2019, and you want to subtract October 14, 2019, then you're going to get a time span of 1 day, because it's one. October 15th minus October 14th is going to be 1 day, so it's the time span is 1 day. So that's what subtract is. Here is some exact statements that some examples. So here's something where we have a date time variable called date time, and we set it equal to March 1st, 2016 at 1:28 p.m. And then we're going to add 2 months to it, and that turns into May 1st, 2016 at 1:28 p.m. And then we're going to add 60 days to it. Okay, this adds 2 months onto this date time and stores it into a new date time variable called due date. So this is not going to change the date time. This is not going to change it to May 1st. This is going to return May 1st, 2016 at this time, and it's going to set this variable due date equal to that date. And this is going to change due date into date time plus 60 days. So date time is still May 1st. I'm sorry, March 1st. Date time is still March 1st, and we're adding 60 days onto it. And so 60 days onto March 1st will be April 30th, because there's 31 days in March. This takes date time, adds 30 minutes, and stores that into a variable called runtime. So it's 30 minutes more than 30 minutes after date time. And then this is something that adds 12 hours onto date time and it returns. So that's why it's 12 hours, puts it over into March 2nd, 1:28 a.m. Here we're using the time span. So first we start out by setting a current date variable equal to today. And then we're gonna set a due date that's equal to February 15th. And then we're gonna subtract the current date from the due date. The current date is January 30th, 2016. That's the current date. And we're subtracting that from February 15th, 2016. That's about 15 days, 16 days. That's 16 days. So time span, it's called time, and here we've named, it's time span variable. It's only like a certain number of days, hours, minutes, seconds, it looks like. It's 16 days, 0 hours, 0 minutes, and 0 seconds. That's what you get when you subtract January 30th, 2016 from February 15th, 2016. You get 16 days. It's a time span. Oh. All right. Time span value represents a period of time stored in ticks. You can use the days, hours, minutes, and seconds properties of a time span to get portions of that value. So you can, these are properties. So if you have a time span here, this is 16 days, and you can get out these specific components of that date time. What is actually stored, okay, a tick is a millisecond. And so, and the way the date is actually stored in the computer, it's the number of ticks since January 1st, the year 11000001. So it's a long time. And so we can compute how many ticks, what's actually stored when we're storing October 15th, 2019, 3:42 p.m. We can convert that to the number of milliseconds since January 1st, 0001, which was back, around the time, I'm rusty with my biblical history, but is that when Jesus was supposed to be born, or was he born December 25th? I have no idea. I don't know. Anyway, you get the idea. It's a long time. So a time span is also just a bunch of ticks, and it's worked out. So if you add a time span onto a date time, you're adding some ticks, or you're subtracting some ticks, and it computes to another date time value. So a statement that uses the minus operator, it's a subtract operator, and we're doing the same. We are subtracting ticks and so on, but we're formatting it into date time, and it's a variable that can be converted into a date time that looks like this. An if statement that uses the greater than operator. So the greater than operator works fine with dates and times. Okay, so that's date time. Now we're going to go to strings. Okay, so there's a string class. It's common, it's a string class stores strings. And so there are some properties of a string class, a couple of properties of a string class. Here, this bracket index end bracket, that is a way to reference or to refer to a particular character within the string. So the first character of a string is the 0th character. The first character is the number 1 character is the second character, and so on. So for example, here, let's say we have a string, and we call the string chars. That's what we call a string, and it's this. A, B, C, D, E, F, G, 7 characters. So the length is 7. 1, 2, 3, 4, 5, 6, 7. Chars dot length is equal to 7. And chars of 0 is equal to the first character. Chars of 1 is equal to the second character. And as you know, as you remember, in Visual Studio, no, I'm sorry, in C#, you specify characters using a single quote, and you specify strings using the double quotes. It's the only language I know of that does it that way. But. So that's two properties of the string class. Code that uses a for loop to access each character in a string. So this is one way to do it, where you can index each character in a string using what we just learned here, use indexing. And so you can loop from 0 to the length to the number of characters in the string, increment 1 at a time. And in this little dumb example here, we're taking our A, B, C, D, E, F, G, and we are looping through all the characters, and we're creating this new character called chars and spaces, characters and spaces. And we are creating a new, we're each time through the loop, we are appending or concatenating the next character followed by a space. So we take A, B, C, D, E, F, G, and we turn it into A space, B space, C space, D space, E space, F space, G space. And then we print it out here, and this is what prints out. And there's a space after each one of these letters. So that's one way of referring to each individual character within a string. Another way is you can use a for each. And so for each character in chars, and for each character we're going to call it C. So for each character C in chars, we're going to do the same thing. We're going to concatenate the character plus a space onto this variable that we've declared here called chars and spaces. And we end up with the same thing like this right here. So here's all the methods that can be used with a string class. So any string variable you can do dot starts with a string, and so these methods here, like if you have this variable called char, let's say you have a variable chars and spaces, and it's this A space B space D, so it's that. If you do starts with A space B, then this would return a true. If you say starts with A C, then it's not going to be true because this string starts with A space B. So this method returns a true or false. This method, the second one here, is going to return a true or false. This third one is going to return a integer value, which will say where the first occurrence of this string is, and the starting position, the starting index value of this string. This fourth method here, last index of, is going to return the starting character of the last, because there could be more than one. So this does the last one. This one will actually insert a string into another string, and it'll return that new string. See, each one of these methods actually returns something. These methods do not mess with the string. The string stays the string. It's not, and these methods just return some value, as when it's operated on the string. So, this the first one true or false, second one true or false. The third one returns an integer value. The fourth one returns an integer value. The fifth one returns another string, and it's going to be the original string with this other string inserted into it, starting at this index. Pad left is going to return a string with the spaces with some additional spaces. Same with pad right. Remove is going to return a string, which takes out some characters. Replace is going to return a string that replaces some characters with some other characters. Substring is going to return a string that's just part of the original string. ToLower is going to return a string, except all of the characters are going to be lowercase. All the letters are going to be lowercase. ToUpper is going to return a string, except for all the letters are going to be uppercase. Trim is going to return a string, except for it's going to hack off the spaces at the beginning and the ending of the string, so it stays nice and trimmed. And split is going to split the string into an array of smaller strings on a split character, and we'll see how that works soon. So, for example, here's code that uses the starts with and the ends with method. So where's this starts with ABC, ends with ABC? Where do we define starts with? Oh, never mind. This is a Boolean variable. We're declaring a Boolean variable here called starts with ABC. And this thing right here, this chars dot starts with parentheses, quote ABC and quote in parentheses. This is a method that's going to return a true or false. It's going to return a true if chars actually begins with ABC. It's going to return a true. So that's why this is a Boolean variable, which can take on a value true or false. And this is going to return whether it ends with ABC. And chars ends with ABC. And chars, of course, is this thing back here, A, B, C, D, E, F, G. So if that's chars, then chars starts with ABC is going to be true. So this is going to be true. Chars ends with ABC is not true because it ends with EFG or whatever it is. EFG. So this is going to return a false. So this is going to take on the value false. Okay, here's another example here. We have this string, the variable, it's a variable name called company name, and it equals this string, Mike, Mirock, and Associates. So the first line here, index 1, returns the index of the first space. 0, 1, 2, 3, 4. So the index of the first space is 4. That's what this first 4 is. This here, and this is a string. This here is going to return the index of the first space character. It's a character, it works the same way. This here is going to return the index of inc period. Well, there is no inc period in this string, so it's going to return a -1. And this is going to return the last index of the space of a space. So it's not going to be this one, it's not going to be this one, it's going to be this one. This is the last space right here. And what is the index? Well, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's why it's 15. Code that uses the remove, insert, and replace methods. Okay, so these are methods that take the string, do some manipulation with it, and then returns a new string. It doesn't change the original string. The original string stays the same. It just returns a new string that's the manipulated value. So let's say we have this company name here, and it's this company name, this Mike, Mirock, and Associates. And we're going to remove from the 0th character to index 1 plus 1. Well, index 1 plus 1 looks like it's 4. So index 1 plus 1 is going to be 5. So this here is going to remove 0, 1, 2, 3, 4. It's going to remove 5 characters. It's going to remove 5 characters starting from the 0th character. So it's going to remove. It's going to remove the capital M, lowercase I, lowercase k, lowercase e, lowercase space. So it's going to remove Mike space. That's what this first one does, and it's going to return that value. So it's going to return, and so this sets the new company name equal to the old company name with the first 5 characters removed. Okay. Now this second thing here is going to insert the characters comma space INC period. It's going to insert those characters at this place, and what this place is it's the length of the company. So it's however many characters company name is. So anyway, it's the end of the string. So this is just going to basically concatenate comma space INC period onto the end of the name. And then this one here, this replace, is going to replace, it's going to go and find this first string, and if it does find it, it replaces it with this second string. So all it's doing is it's taking a lowercase and it's replacing it with an uppercase a and. And so when we're all done, and you notice each time it's setting, it's taking the old company name and then saving it into the new company, saving it back into company name again. So after these 3 statements are executed, company name is going to look like this. There's not going to have a Mike in front of it. It's just going to be Muroc and Associates Inc. Capital A for and. Okay, here's some code example that uses substring to upper and to lower. And so here we have a string. We've named this string first name, and we've set it equal to and with an E. Maybe it's Annie. And here we're going to take first name, which is Annie, and it just grabs off a substring starting with the 0th index, just 1 character. So it's going to be just the letter A. And it's going to capitalize it. So it's going to take that letter A and it's going to make it an uppercase A. And that's it's going to be stored in this first letter. And then there's a second string variable here called other letters. And basically what that does is that's going to take first name, which is still A-N-N-E, and it's going to take a substring of that starting with the first index, not the 0th index, but the first index. In other words, starting with this first N. And the substring method does not have a second parameter, so that means it's just all the rest of the substring, starting with the first index, not the 0th index, but the first index. So this first name dot substring of 1 dot to lower is just going to take the NNE and make it lowercase. It's already lowercase. That's fine. So other letters is going to equal NNE. And then what we're doing here is we're redefining first name. And first name is now going to be this first letter, which is a capital A, followed by lowercase NNE. And we end up with this, uppercase A and E. So, here's just an example of how an assignment statement works in strings, and you know we actually copy when we set one string equal to another string, we're actually copying one string over into another string. So if we set S1 is equal to ABC, and then we set S2 equal to S1, and then we set S2 equal to DEF, well, S1 is still going to equal ABC. Okay, that's not the case in other languages and variable types. So here's one. Okay, so what we're going to do here now is we're going to go through a brute force way of parsing. Okay, so let's say we have this name here, this variable called full name, and it is the name of the variable, and it's equal to Edward C. Coop, a space, Edward space C space Coop space space space. Okay, that's what it's equal to. The first thing we're going to do is we're going to take full name, we're going to trim it, and set that back equal to full name again. And so when we trim it, it's going to trim off the spaces before Edward, and it's going to trim off the spaces after Coop. So we're going to end up with just this thing over here, which is no space, and then Edward space C space Coop, and then no spaces. So there's only 2 spaces now in the full name, whereas before there were, you know, 1, 2, 3, 4, 5, 6, 7. And then what this does is this is an integer. So it's the integer is when we're going to call it first space. And what it is it's the index of the first space in full name. So that would make it 0, 1, 2, 3, 4, 5, 6. So that's the index of the first space in full name. It's 6. That's what the 6 is here. So this is going to be a value 6, this thing. So 6 gets stored into first space. Okay, now we're going to create this new variable called first name, and we're going to set it equal to empty string to start with. Okay, then we're going to do this if statement here. If first space is equal to -1, okay, what would that mean? If this first space, if this integer here is, if this integer, in other words, if this integer here, if that integer is equal to -1, then that means it didn't find any spaces. It means it didn't find any spaces in full name. Okay. Well, there is a space in full name, but this takes care of the case where there's no space in full name. And so if there's no space in full name, then it's going to assume that the full name is the entire first name. The entire full name is the first name. So in other words, if full name was just the word Edward without any spaces, then it would set first name equal to Edward. However, the else case takes care of when full space is not -1. First space. If first space is not -1, then that means first space is a value, and which means there must be a space. The value is the index of the first space, which is right here. And then so what this does, if this says that first name is equal to a substring full name starting with 0 all the way up to the first space. So we're saying that first name is just this. That's what that is there. So this says it's 6 characters starting with index 0. So 6 characters starting with index 0 is 1, 2, 3, 4, 5, 6. That takes care of just the full word Edward. So that is a way to grab off the first name. Looks pretty complicated. Okay, let's go to the next one. Here's a code that parses a string that contains an address. So here's an address, and the fields of the address are separated by these vertical bars. Often the fields of an address are separated by a tab character, or they're separated by a comma character, In this example, they're separated by a vertical bar. So what we want to do is we want to grab out, we got this city index, state index, street, city, state, zip code. Okay, so and we're always looking for the index of a vertical bar. So we start by looking for, we do a trim first to make sure that it starts with a vertical bar and it ends with a vertical bar. So this thing, so it's going to trim off these spaces here, in which case it'll start with a vertical bar and end with a vertical bar. And then it's going to go look for the first vertical bar, and that's the index, where the city starts. Yes, this vertical bar, first vertical. Wait. I think we might remove the, I think we removed, yeah, we removed the first vertical bar. So this vertical bar is going to be gone. This vertical bar is going to be gone. So, so the city index starts here. The state index starts here. The zip code starts here. Anyway, when we're all done, you know, you can believe this. When we're all done, we've got a string that's got just the street. In other words, it's got just this part. And then we have another variable called city that's just got this part. And then we have another variable called state that's just got this part, this TX. And then we have a final string called zip code that's just got this part right here. So that's, this is a lot of code when all we're doing is we're trying to parse this string into its component, into its address components. Add the street address, the city, the state, and the zip. Well, another way we can do that is we can use the split method. With the split method, we split the string into an array of smaller strings. So here we first we trim it to trim off the spaces. We always still want to trim off the spaces, and then we're going to split full name on the space. See, we're splitting full name on the space. It's that space there, and that's going to go into an array of names, which means, see, it's a string array, which string, it's got these brackets here, which means it's an array. So it's going to be a string of names. So there's going to be a names 0, a names 1, a names 2, a names 3, and so on. Names 0 would be this one. Names 1 would be the C, and names 2 would be the coupe. But in this case, we're only looking for the first one. And then for this address split thing, first we got to trim off the spaces and so on. I think we want to pop off the first vertical bar and pop off the last vertical bar. It's not necessary to do that because we can just make the indexes 1 greater. But anyway, what this does is it splits the address into an array of columns, and columns 0 is the street address, columns 1 is the city, columns 2 is the state, and columns 3 is the zip code. And we use the split method to do that. Here's some fanciness that adds, how to take a phone number that looks like this and to insert hyphens. You want to insert a hyphen after the 9-7, after this, between the 7 and the 5, and then you want to insert a hyphen between the 5 and the 1. And so here we're inserting at the 3rd index we want to insert a hyphen, and at the 7th index we want to insert a hyphen. So it's gonna it's gonna be 0, 1, 2, 0. Oh, I guess it. Okay, I guess it must be like just before the third one. No, it's after the third character. After the third character. 0, 1, 2, and this after the third character, you put a hyphen. And then after the seventh character, so it's 1, 2, 3, 4, 5, 6, 7. After the seventh character, you insert the string. So that's what that does. And instead of doing hyphens, you can do, here it replaces hyphens with slashes. So it uses this replace. And this is gonna this will replace all of the dashes with, all the hyphens with slashes. So now we're going to talk about parsing and try-parsing for validating decimal values. You've used parse and try-parse already to validate values, but there's some fancy options for parse and try-parse. Parse is just having one, the parse method of just having one parameter, and the try-parse method of having two parameters. But you can, after the first parameter, you can throw in some style parameters. And what these style parameters do is it will allow additional characters in the string. Okay, so let's say you've got the string and you want to convert it to a number, but that string has a $ in front of it, okay, because it's money. So you have this string, it's some money, and it's got a $ in there. It could be like $10,000, okay? It's got a $ in front, it's got some commas in there, it's got a period in there, but you want to convert that into a decimal number. And you don't want to have to parse and mess with it and look and see if there's a $, take off the $, look and see if there's some commas, take out the commas. You don't want to do that. So you can just add these style parameters here. This will allow a currency symbol. This will allow a decimal point. You can have some white spaces in there, and that you can allow that. You can have some trailing white spaces. You can have a plus sign, meaning it's a positive number, or a minus sign, or you can, there's a bunch of things you can have. You can, in accounting, you may specify negative numbers with parentheses. You may have some commas in there. You can take those commas out. Currency, okay. Or you can say, nope, can't have any of that stuff. We just want digits. So here's a parse method which allows entries with any decimal characters. So if you say number styles dot currency, it's going to allow all that stuff. Currency allows digits and all of the above characters, styles, the commas, parentheses, $, everything, general. So that's what this does. You can just put number styles dot currency, or when you try parsing, you put the number styles dot currency. You can also put more than one. See, so this has two of them, and you separate. It's still the second parameter, but just separate them with a vertical bar. I don't think this comma is supposed to be there. This doesn't look right. Anyway, okay, so Okay, so now there's this, now we're going to do the string builder object. It's very similar to a string object. Took me a while to figure out the difference. The difference between a string, the string builder object, and a string is with all of the methods of a, remember when we were talking about all the methods of a string object, it never changed the string itself. Instead, it returned a new string. And if you wanted to, you could set the old string equal to this new string. Okay? Or you could set the new string equal to something else, some other variable name. With the string builder, these methods actually change the string itself. You actually manipulate the string itself. And the string builder is flexible in other ways that's kind of transparent to the programmer. It's for the string builder, it's designed to be able to vary in length much more easily than a string object. The string builder object is more easy to manipulate than the string object, and it's just for efficiency purposes. You, the programmer, can decide whether you want to use a string builder or a string, but it's pretty much interchangeable. So here we're so when you initialize a string builder variable, you can say an initial value, and you can also say an initial length or a capacity or a size. And that's okay. It's the initial size. If it grows and it has to be bigger, like it's 10. If it has to be bigger than 10, it just expands, and the programmer doesn't really have to do anything. It doubles actually. So here's an example. We're setting a string builder variable called phone number 1, and we're setting it equal to that. And so to use a string builder class, you have to use a using up here, whereas a string is more of a primitive object. String builder it's a .NET class, so you got to have this using up there. The common properties of a string builder class, similar. You have an index, you have a length, but you also have a capacity. So you can find out what the current capacity or the current size limit is of your string builder variable, but it doesn't matter if you end up growing it beyond the capacity, it just expands. It just expands the capacity automatically. There are these methods here: append, insert, remove, replace. They're similar to what you might expect, except for when these methods are executed, you're actually changing the string itself. You're actually changing the string builder variable itself. You aren't returning a new string. You're changing the actual string itself. So here we got this string builder variable called phone number, and we're doing a bunch of stuff to it, and in the end, it's going to be different. It's not. You notice these are methods. That's the standalone methods. It's not like these are on the right side of an equal sign. It's not like these are returning values and you're storing it into another variable. It just manipulates the variable itself. So there's a method called there's a format method, which is part of the string class, and it's a way of taking a number or something and formatting it in a way that's defined and uniform. And so here this is kind of a little bit confusing. Let's see some examples here. You should be familiar with a lot of these. These are like if you want to display out numbers with these formats, if you want to display it out as currency, it'll put dollar signs and decimal places and so on. if you want to just display it out as a decimal number or an integer with a certain number of digits, so it'll probably right justify. A scientific notation. This is a floating point number with a specified number of decimal places, and this is scientific notation that's more compact, I guess. I see what that looks like. This N format will throw some commas in there for thousands, and the P will be a percent. And then there's these other custom formatting codes. So if you want to design your own formats, and these are digit placeholders and where the decimal point goes and commas and so on. So here is statements that format a single number. Okay, so here's how it works. Okay, you got this. You have this variable. It's a string variable, and it's called balance one. And what you want to do is you want to store something into balance one, a string. What are we storing? We're storing 1234.56. Okay, that's what we're storing. That's the number we're storing in there. But we're formatting it with a C format code. The 0 here refers to it means this number here. So this, let's see if there's the 0. Here, let me try to find. Oh, here's where there's a 1. Okay, so this takes 1234.56, formats it like currency, and so it's going to look like this: $1,234.56. So this $1,234.56, that's what's going to be stored in balance one. In balance two, we're storing minus 1234.56, but we're specifying a much fancier format here. This format here, it says we're going to have a $sign in front of it. So this is the positive. This is when it's a positive number. It's going to have a $sign in front of it. It's going to have some commas. It's 1,000 spaces. It's going to have 2 digits to the right of the decimal point. If it's a negative number, it's going to put parentheses around it, just like accounting. So this whole thing specifies the format of this number, turns it into a string, and stores it in this string variable. Here's a third one, which this is the big, long, fancy format, and it includes a 0. So if it's a positive number, it does this first one. If it's a negative number, it does the second one. And if it's 0, it writes the word 0. Here's a case where it's taking the number 43 and it's saying that it's a 3-digit number. So it's going to look like that. Here, it's going to take the number 432.8175, and it's going to say it's a floating point number with 2 digits to the right of the decimal point. So it's going to end up looking like this. It rounds it to. Looks like. And here's something that formats 2 numbers. So it's a string, and there's 2 numbers involved. This is the first number, and this is the second number. So this is a string, and it's going to have this number in it. It's going to have this number in it, and this is how the format's going to be designed. This first one that's what the 0 is. So the first one is going to be formatted like currency, and the second one, this one here, is also going to be formatted like currency. So it's going to output, it's going to have this thing first, and then this is where the number is going to go. And it's going to have this thing next, and this is where the second number is going to go. So that's why it ends up looking like this. So here's there's date time formatting codes. If you're doing a date and a time and you want to do a format, you want to format into particular date and time. These are the codes for that: short date, long date, short time, long time, and so on. These are some more date formatting codes. If you want to do the day of the month with leading zeros, day of the month day of the month without leading zeros, day of the month with leading zeros. This is like the 3-letter day abbreviation, MON, TUE, WED. This is the full day name, Thursday, Friday. This is month without leading zeros, month with leading zeros, abbreviated month name like MAR or JAN. This is the full month name, 2-digit year value without leading zero, 2-digit year value with leading zero, 4-digit year value, and a date separator. Hours, minutes, seconds, same kind of thing here. You can have leading zeros or not leading zeros, depending on how much you want to display it out. 24-hour time or 12-hour time, AM and PM or 24-hour time, and so on. So here's how we use them. This is how you would display out the lowercase d, uppercase d. This refers back to these day of the month without. No, it refers back to these formatting codes, short date, and these are for the custom codes. So this is short date, long date, short time, long time, and here we're doing fancy formatting. You know, SAT, JAN, the day without a leading zero, and then the full year. Throwing some slashes in there. So depending on how you want to do it. Okay, there's another way of formatting. It's called interpolated strings. I don't know if you're ever going to use this. This is new. It's sort of a way of, it's a string, it's got a $sign in front of it, and by interpolating, it means that it goes through this, what's inside these curly braces, and it replaces stuff. Like, almost done, like here. So we have a balance, we have this balance value, and the value we're going to store in there is 1234.56, but we want to format it like currency. And so this is another way of doing that formatting. We sort of cram it all together. It's sort of an inline formatting kind of thing. So that's why it's called inline. It's interpolation inline. So it's going to end up looking like this after it's formatted. It's still the 123.56, but it's formatted like a currency. And the way you declare that is you put a $sign there and some quotes and stuff. This is a much fancier way of doing it. It's the same sort of formatting codes, but it's this inline interpolating thing. All right, it's 427, and the rest of this stuff is just this is exercise 9 dash no. Okay, this is extra exercise 9-1, and so these aren't very long exercises. So we're going to do 9-1 on Thursday, and we might do 9-2 on Thursday also. We probably will because they're pretty short. And we're not going to do anything more than that. All right, so that's all I have today. And so are there any questions? Brandon, any questions? You're good, I'm sure. Nope. All right. Okay, so I hope this helps. And thank you, everybody, for coming today. And we will see you on Thursday. Thanks for watching.